One of the major updates in Collection API is the introduction of sequenced collections. In Java, collections come in different flavors. Some collections keep the order you add elements in, others don't. Some automatically sort your elements, and others just store them however they like. Lists, for example, preserve insertion order. If you add A, B, and C to a list, when you retrieve them, you get A, B, and C, just the way you added them. Sets, on the other hand, don't allow duplicates, but the order depends entirely on the implementation. Then we have sorted set, which keeps elements sorted by their value, regardless of how you added them. It's really important to understand the difference between an ordered collection and a sorted one. Ordered means the collection preserves the sequence in which you added elements. Sorted means the collection arranges elements based on their value, either naturally or using a comparator, and doesn't care about the original sequence. For example, if you create a list and add elements A, B, and C, you'll get them back in the same order. But if you use a tree set, which is a type of sorted set, and add numbers like 5, 2, and 9, it doesn't matter how you added them. When you retrieve, they'll come out sorted as 2, 5, and 9. The order in which you encounter elements when you iterate over a collection is called encounter order. Lists always guarantee a stable encounter order. With hash set, the order is unpredictable and might change depending on the internal rehashing. But with linked hash set, encounter order stays stable, meaning the elements comes out in the same sequence they were added. The problem is that before Java 21, there wasn't a clean, consistent way to work with first or last elements of different collections. You had to rely on hacks like using list.get methods for lists or messy iterator logic for sets. This is exactly the problem sequenced collections are designed to solve. In Java 21, sequenced collections was introduced to unify how we work with collections that have a predictable encounter order. It's a new interface that adds methods to easily access or modify the first and last elements of a collection, no matter if it's a list, set, or something else. The interface looks something like this. It has all these methods. You can use these methods on lists, linked hash set, dequeues, and even on certain types of maps. You can also get a reversed view of the collection without physically copying the elements, which is super handy. We can achieve this by calling the reversed method. Let me show you how this works with a simple example. You can create a sequenced collection using an array list, add elements to both the front and the end, and retrieve them consistently, like you see here. It works similarly with linked hash set, which now implements SequencedSet. You can get the first and last elements of a linked hash set reliably and reverse its view as well with this code. Now, an important question people often ask is whether sorted set implements sequenced set. The answer is no. Sorted set, like tree set, sorts your elements automatically based on their values. You can't control where elements go. The sorting logic decides that. So it doesn't really make sense to add elements at the front or the end of the sorted set, which is why sorted set and sequenced set are intentionally separate. Maps also benefit from new sequenced collection model. The new SequencedMap interface allows you to add first and last elements, retrieve the first and last elements directly, and reverse the entire map view as well. And here is a sample code for the same. Dequeues and queues also implement sequenced collection now. They've always supported adding or removing from both ends, but this new model aligns those methods with a consistent API, which makes the code easier to read and maintain. Let's also quickly recap where this all fits in collection hierarchy. So you have collection at the top, extended by sequenced collection. Both list and dequeue implement sequenced collection. Linked hash set implements SequencedSet, and linked hash map implements SequencedMap. These interfaces make it easier to work with ordered collections across the board. Hope it makes sense. I'll see you next.